All right, pre-algebra students, what we want to work on today are some skills that we will use when solving equations. So we've been looking at proportions, which are a specific type of equation, and how to solve those. What I want to start looking at now are just some skills that will help us when we see other equations to solve. One of those skills is the distributive property. I'm sure you've seen it before. I know you know how to work with it, but we just want to refresh ourselves on the distributive property. And the other thing is collecting like terms. Knowing what is going on in an equation will require us to identify like terms, and then how do we collect those terms together. So the distributive property mathematically looks like this. A parenthesis B plus C. And we know between the A and the parenthesis is a multiplication sign. And the distributive property says you can take A and multiply it to B and get AB. You can take A and multiply it to C and get AC. And if there's a plus sign between the two, you can put a plus sign between these two. Being able to consistently distribute correctly and accurately will determine whether or not you will be able to correctly and accurately solve equations in algebra. So, practicing the distributive property is important. What is 2 times 3x minus 5? Well, break it down one step at a time. That's 2 times 3x minus 2 times 5. 2 times 3x is 2 times 3 times x, right? Because between the 3 and the x is times. So 2 times 3 is 6. 6 times x is 6x minus 2 times 5, which is 10. Now, at this point, one mistake kids will make is they will combine these terms, and that is incorrect. When we look at terms in algebra, we call like terms things that look similar, and things that don't look similar, we don't have a name for it, they're just not like terms. Because this term, and terms are separated by subtraction or addition signs, because this term has an x to the first power, and this term has no x's, they are not like terms, so we can't combine them. Another common mistake is 2x squared minus 5x plus 4. Students will try to combine these because they both have x's. But algebraically, they cannot be combined because the x's are being raised to different powers. Now, this is when we're talking about, again, terms that are separated by addition and subtraction. The reason I think kids can get confused here is because if it had said 2x squared times 5x times 4, you can multiply all these together. So if we look over here, what we have going on is we have 3 terms, 1, 2, and 3. And I don't want you to think those are division symbols. But if you can count those 3 terms, separated by addition or subtraction, we've got a 2x squared. Only if there's other terms with x squareds in them can you combine them. Since this doesn't have an x squared and this doesn't have an x squared, it's just 2x squared. Now 5x, and it's a negative 5x. We can think of this as a plus a negative 5x. So now I'm looking at this negative 5x. This isn't an x. That doesn't have just an x to the first power. So the minus 5x or the plus negative 5x just stays right there. And then lastly, this 4 can only be combined with other constants. There's no other constants, so it's just 4. So you might be saying, well, you didn't do anything there, and that's because there is nothing to do here. This is completely simplified. Now back to this question, which is not the question we're working on in this unit, but it bears showing out. When I say 2x squared times 5x times 4, what I'm really saying is take 2 and multiply it by x squared, and then multiply that by 5, which is being multiplied by x, and then multiply that by 4. And when I say x squared, I'm really saying take 2, multiply it by x, multiply it by x, multiply this by 5, multiply this by x, multiply this by 4. And this is something we can simplify. We know 2 times 5 is 10, and we know 10 times 4 is 40. And we know if x times x is x squared, then we know x times x times x is x cubed. And so no wonder it's confusing seeing this, and one you can do and one you can't. Which is why I like to say a lot in high school math that adding and subtracting are hard. Multiplying and dividing are easy. I say this all the time because when you're multiplying, you can pretty much just multiply everything together most of the time and get the correct answer. When you're adding and subtracting, you have to be very careful about like terms. So let's try another example with the distributive property, and you may notice that this example looks familiar because it was on the last test in pre-algebra. Maybe not exactly this problem. 2 times x minus 5 plus 3 times 2x plus 1 minus 4 times 3x minus 8. When I was in pre-algebra, one of the skills I learned was going through whenever I see a minus sign and making it plus the opposite. I think that's a very valuable skill right now, is seeing this as plus the opposite. So right now all I've got is I've got 3 problems where I have something being added up in parentheses that's also being multiplied by a number. So now I'm going to take these 3 one at a time with 3 different colors and just deal with what the distributive property would give me. So in this first one, I would take 2 times x plus 2 times negative 5. In the second equation, and now I'm just going to bring this big plus sign down. I'm going to make this one bigger because it's going to separate the distributive property questions. Okay, so this simplified with the distributive property. Now the next question, I'm going to take 3 times 2x, and then I'm going to take 3 times 1. This plus sign here just comes on down. And now I'm going to take this plus sign here, which is big, right? Separates the next distributive property question. And now I'm going to take negative 4 and multiply by 3x. And I'm going to take negative 4 and multiply by negative 8. And this plus sign just comes on down. If I wanted, I could have put this 3 in parentheses and this 3 in parentheses. I could have put this 2 in parentheses with this x here and this 2 in parentheses. Now we just simplify each one of these multiplication problems. 2 times x is 2x. 2 times negative 5 is negative 10. 3 times 2x is 6x. 3 times 1 is 3. Negative 4 times 3x is negative 12x. And negative 4 times negative 8 is positive 32. Now those big plus signs haven't gone away either. But what I want you to see is that in these kind of columns, we just have done the distributive property by changing the minus signs to plus the opposite and then just taking our time to multiply. Now I've got one big problem. All the parentheses are dealt with and gone. And now all I want to do is go through each term, and there's 1, 2, 3, 4, 5, 6 terms, right? All separated by addition signs. And for those 6 terms, I just want to see if there's other terms that are like them. I have a 2x. And another term that is like 2x is 6x. And another term that is like 6x is negative 12x. Those 3 are like terms. So I'm going to take 2x, I'm going to add 6x, and I'm going to add negative 12x. Now I'm going to look for terms that might look like negative 10. That's just a number, no x's with it. 3 is just a number, no x's with it. 32 is just a number, no x's with it. So I'm going to add negative 10 with 3, and then I'm going to add 32. Now, if you want to, feel free to use a calculator to add this up, but if you don't need to and you want to practice without, that's good too. 2x plus 6x is 8x. 8x plus negative 12x is negative 4x. Negative 10 plus 3 is negative 7. Negative 7 plus 32 is positive 25. And now I have my final answer to this beginning problem. It's kind of a short video, so I recommend that you rewind it and watch it again. If you watched it the first time taking notes, then I want the second time to be no note taking, just listening and watching. And if you do it at double speed, you're going to have to watch it twice, because I think just watching this over and over and seeing again how you can break this down one at a time. If you need to develop your scripts, try writing those out on a piece of paper for this. How do you go through the distributive property? How do you go through the process of looking for and collecting like terms? What were the questions I was asking, and how was I answering those questions? All right, pre-algebra students, hope you have a great night. Peace.